All right, lecture 19. Today we are doing quadratic equations, part 2, difference of squares and rainbow method. Okay, so the last time we talked about quadratic equations, we were doing simple trinomials, right? And we know that we can multiply to the last number and add up to the middle number. So, for example, we did things like um, for example, we did x squared plus 7x plus 12 equals 0. And we know that we can factor this, right, by multiplying to 12 and adding up to 7. So I would put the m above the 12, I would put the a above the 7, and then I would just find out what two numbers will do it. What two numbers will multiply to 12, and what two numbers will add up to 7. And of course, we're going to have 4 and 3, right? So I put down the 4, I put down the 3, and now I know what my two numbers are going to be when I factor. So I could have x plus 4 and x plus 3. And everything is still set equal to 0. So those would be my two factors, right? And then what I would do after that is I would set both of them equal to 0 and then see what happens. So I would have x plus 4 equals 0, and then I would have x plus 3 equals 0, and then I would solve them both for x. So all I'm doing is I'm taking what's inside the parentheses and I'm setting them equal to 0 and just seeing what happens. So when I do that, I have to subtract 4 on both sides. I get x equals -4. So that would be my first answer. And then over here, I would have to subtract 3 from both sides. And you're going to get -3 as your second answer. So then, once I know what my two answers are, I'm going to put them in my solution set. And it's just going to be a set containing the numbers -4 and -3. So these two are the only two numbers that would solve this equation. It doesn't have any other solutions besides those. Okay? Now, last time we also talked about what a general quadratic equation looks like. And quadratic just means your highest exponent is going to be 2. So we talked about, ax squared plus bx plus c equals 0. And we were talking about quadratic equations. We know that the highest exponent here is going to be 2. We know that x is going to be a variable. And we know that a, b, and c are just real numbers, right? So a, b, and c are all real numbers. Okay? So that's what the a, b, and c are. They're just real numbers. And besides that, we also stipulated that a cannot equal 0, right? We also know that a cannot equal 0. And it's pretty obvious why, because if you do let a be 0, what happens? Well, if a is 0, then if we're multiplying anything by 0 right here, the whole thing is going to turn into 0, right? So your ax squared is going to be equal to 0. That means that it's pretty much not there anyways. You would end up with bx plus c equals 0. And that wouldn't be quadratic anymore, would it? That would just be a linear equation at that point. So we can't let a be 0, but what if b was 0? What if b equals 0? Then what would happen? Well, if b was 0, then we would have, instead of this, we would have ax squared. And since b is 0, this whole linear term just goes to 0, right? So there's no bx anymore. And then you would just have plus c equals 0, right? So this is what would happen if B was actually 0 instead of A. You would end up with this right here. So then what would happen is you would end up with something called difference of squares. You would end up with difference of squares. And that's what I wanted to talk about today. So difference of squares. We're going to do a couple examples of these. And then after that, we're going to head up into the rainbow method, see how that works. And then after that, we should be done for today. So let's look at a quick example of what difference of squares means. Let's say I had something like x squared minus 9 equals 0. And I wanted to figure out what x is. Well, we can factor this by using the formula that we learned in lecture 2, right? In lecture 2, we learned that difference of squares has a formula. It's x squared minus a squared equals x minus a times x plus a. If you ever see a square number like 9, we can break that down into square roots, right? So what's the square root of 9? The square root of 9. That would just be 3. So this is going to become x minus 3. So I got my minus, but I also need to have a plus factor, right? So over here, I'm going to have x plus 3 instead of x minus 3. And the whole thing is still set equal to 0. Okay? So now what I can do is I can take both of these sets of parentheses, I can set them both equal to 0, and figure out what x would have to be to solve it. So I have x minus 3 equals 0 for this first one. And once again, all I'm doing is I'm taking this whole thing and setting it equal to 0. But then I would have to take this thing right here as well and set it equal to 0. So I would have x plus 3 equals 0. Okay. So I've got two different equations to solve. And for the first one, I'm going to add 3 to both sides because I know that I can get rid of that negative 3 by adding 3, right? So I get x equals 0 plus 3, that's going to be 3. So that's my first answer. So now I look at this one and I do the opposite. Instead of adding 3 this time, I need to get rid of a plus 3. That way I'm going to subtract 3 from both sides. So I'm going to minus 3 from both sides of the equal sign, and we'll see what happens. The plus 3 and the minus 3 are going to cancel out. 0 minus 3 is going to give me what? Negative 3. So those are my two answers, and I put them inside of a solution set. Okay? So now let's check our answers. We're going to check x equals 3 over here. And then over here, we're going to check x equals negative 3 and see what that gives us. So now we're checking. I take both of my answers, and what I'm going to do is I'm just going to put them into the original equation, right? I've got x squared minus 9 equals 0. X squared minus 9 equals 0, because that's what they gave me when I first started. I'm always plugging back into the original equation that they gave me in the first place. Okay, so that means everywhere I see an x right here, I'm going to put in positive 3. And then over here, everywhere I see an x down here, I'm going to put in a negative 3. Make sense? All right, so let's do it. I put my 3 in parentheses, and I'm going to have to square it. Subtract 9 equals 0. Okay? Now, I know that 3 squared is going to give me 3 times 3, which is 9. So I'm going to have 9 minus 9 equals 0. And indeed, that's going to give me 0 equals 0. So this one, I know it's going to work. So 3 is definitely going to solve this. Now I look at the negative 3 over here. The only difference between these two answers is one of them is positive and the other one is negative. So really, when you square these two numbers, you're going to get the same thing, because what's negative 3 times negative 3? The negatives cancel out, right? That just gives me a positive 9. So let's plug in negative 3 right here. So when I do that, negative 3 times negative 3 is going to give me that positive 9 that I want. And then I get 9 minus 9 equals 0. And then 9 minus 9 is 0. So I get 0 equals 0. Good. So that's how we know the check is going to work. It's because I get this true statement at the very end. 0 equals 0. So let's do a couple more problems like that. Let's do x squared minus 36. X squared minus 36 equals 0. Okay, now for this one, I've got to make sure that I find the square root of 36 this time. So what's the square root of 36 going to be? It's going to be 6, right? So I can factor this as x minus 6 and x plus 6. And the whole thing is still set equal to 0. Okay? So all I did was I factored it. So now I've got two different factors. I can set both of them equal to 0, so I get two different equations I need to solve. I'm going to get x minus 6 equals 0 for that first one. And then for this one, I'm going to get x plus 6 equals 0. And I solve them both. Okay? So for this first one, I'm going to add 6 to both sides. That's going to get rid of that minus 6. And I get 0 plus 6. We know that's going to be 6. Over here, I've got an x plus 6. To get rid of that plus 6, I need to subtract 6 from both sides. So that's going to give me negative 6. So now I know what my two answers are going to be, 6 and negative 6. All right, that's my solution set. And in the interest of time management, I am not going to check this one, but you can if you want. You're going to be able to get 0 equals 0 at the very end, I promise you. Okay, let's do this last one. Okay, for this one, it's going to look a little bit different. X squared equals 81. X squared equals 81. Okay, this one, I do have that x squared. My highest exponent is 2. So I know for a fact that this is a quadratic equation, right? It's not linear, it's quadratic. And at this point, what I want to do is I want to get rid of that 81 from this side, because I want this one to look like the one up here. I want to get 0 on the right side. So how do I get rid of a positive 81? Wouldn't I have to subtract 81 from both sides? So let's do that. We're going to subtract 81 from both sides and see what happens. Okay. Over here, I know that 81 minus 81 is going to give me 0. And then over here, what do I get? Well, these two terms don't really subtract that well. So the only thing I'm going to have to do is put them together. And I get x squared minus 81 is 0. Okay? Now I have something that I can factor, right? I've got x squared minus 81 equals 0. Now I can factor it by finding the square root of 81. And we know that's going to be 9, right? I get x minus 9 and x plus 9 equals 0. So that's the way I'm going to factor the left side. And the right side is still equal to 0. Okay. So I set both of them equal to 0. I'm going to get two different equations. x minus 9 equals 0, and x plus 9 equals 0. Good. Okay, so for the first one, I'm going to add 9 to both sides. And you're going to get x equals positive 9. Over here, I'm going to subtract 9 from both sides. And you're going to get x equals negative 9. So those are going to be the two numbers that I'm going to put in my solution set. Done. Okay. Now checking this one is actually pretty easy, because all you've got to do is let x be 9 and let x be negative 9 and see what happens. So if I do this, let's check the positive 9 first, and then let's check the negative 9. So my original equation was x squared equals 81. That's what they gave me when I started off, so that's the one that I'm going to use. Let's let x be 9 and see what happens. I get 9 squared equals 81. And what's 9 times 9? That's going to be 81, right? Good. I get a true statement, as you can plainly see. And then over here, same thing. My original equation was x squared equals 81. So then I can put in a negative 9 for x and see what happens. So over here, the only difference is negative 9 times negative 9 is going to give me positive 81. So it's not really that different. You still get that true statement at the very end. So that's how you know negative 9 is going to work. Okay? So that is difference of squares. I think the first 6 questions on your homework tonight is going to be difference of squares. And what you'll notice about all the questions is you can factor them all just like this. And your answers are always going to be a positive number and its negative counterpart. So you're going to have the same number for your answer. It's just one of them is going to be positive and the other one is going to be negative. And that's always going to happen for these questions. Okay, I'll leave that up there for a few minutes and then we'll get to rainbow method. Okay, now for the rainbow method, I'm going to be looking at the problem sets that I posted. And the problem sets are just for practice. I don't really take grades on them like I do the classwork. So let's look at a couple of the problems that I have here. All right, we're going to be looking at number 7 on this page. Okay, so 7 says 3x squared plus 8x plus 5 equals 0. We're going to be looking at this one first. Okay, now the whole reason why we're using rainbow method is because I can't find two numbers that'll multiply to 5, but at the same time add up to 8, right? It's really impossible. So I'm trying to find two numbers that'll multiply to 5, but at the same time add up to 8. Can we do it? No. There's no way I can find two numbers that'll actually make this work. So what really should tip you off, though, is this number out in front, this 3 right here. That's going to tell you use the rainbow method, because if I have any number other than 1 right here, I've got to actually draw the rainbow from the first number to the last number. So let's do that. I'm going to draw the rainbow from the first number to the last number. from 3 to 5. And over here, I'm going to draw my MA chart so I can organize all this information that I got. Okay? Now, whatever numbers that the rainbow hits, you actually have to multiply together. So what's 3 times 5? 3 times 5. That's going to give me 15. So I put that number on top of the rainbow. That's going to be my multiplying number. So when I get to my MA chart over here, I'm going to put that rainbow number under the M. So I'm trying to find two numbers that multiply to 15, but at the same time add up to what? They got to add up to that middle number, right? They've got to add up to 8. So I put the 8 under the A because we're adding up to 8, but multiplying to 15. So what two numbers will do that? 3 and 5, right? That'll do it. So when I get to my middle term, I'm going to break this up into 3 and 5. 3 and 5. Now, since I'm actually adding up to an 8x and 8x, I've got to put x's on both of these numbers to make it work. Otherwise, when I get to the grouping step, it's not going to work. You're not going to be able to take out what you need to take out to be able to do it. So I'm going to put x's on the 3 and the 5. Okay? So now what I'm going to do is I've broken up my middle term into 3x and 5x. And now I'm going to bring down the pieces on the left side and the right side. I'm going to bring down the 3x squared, just as I see it. And I'm going to bring down the 5 over here, just as I see it. And then everything is separated by pluses. So I'm going to put a plus here and a plus here. Okay. So now I've got 4 terms. I've got 2 on this side and I've got 2 on this side. And now I'm going to group the first 2 and the last 2. So I'm going to call this group 1 and I'm going to call this group 2. And now we take out our greatest common factors, right? Our greatest common factors. So you're going to be asking yourself, what do these 2 terms have in common? And what do these 2 terms have in common? Let's start right here. What do these 2 terms have in common? Well, they both have a 3, so I can take out a 3. But also, they both have an x, right? So I can take out an x as well. And I'm going to have something left on the inside. Over here in this group, what can I take out? What do these 2 terms have in common? Only a 5, right? They only have a 5 in common. And I'm going to have something left on the inside when I get done with that. So what's going to be left on the inside? Well, to get back to x squared, I'm going to need another x, right? If I want to have 2 x's, I need to have an x right here and an x right here. So the x is going to go here. I bring down my plus sign. And then I need a placeholder 1. So x plus 1 is going to go on the inside. Over here, same thing. I need another x to go right here so that when I multiply these 2 terms together, I get 5x. I bring down my plus, and then I need a placeholder 1. Keep in mind that the insides always have to match up. So this should always match up with this. If they don't match up, that means you did something wrong somewhere. So now the outside parts, remember those, I called them my GCF. We're going to put those together. So I'm going to have 3x plus 5. And then over here, I'm going to merge these 2 copies into 1. to give me an x plus 1. So I basically just merged them into one copy. And now I'm factored, right? I set the whole thing equal to 0. Good. So now I can set up my two equations like I've been doing. I'm going to set this parentheses equal to 0. I get 3x plus 5 equals 0. And then over here, I'm going to set this one equal to 0 as well. I get x plus 1 equals 0. So now I'm ready to solve them both. Let's do this one first since it's the easiest. Subtract 1 from both sides. You get x equals -1. Good. Over here, this is a two-step equation because I need to get rid of the 5 and I need to get rid of the 3, correct? So I'm going to subtract 5 first, just to get rid of that plus 5. And I get 3x equals -5. So far, so good. I've gotten rid of the plus 5. And now to get rid of the 3, I'm not going to subtract 3, right? These are connected by multiplication, so I'm going to divide by 3 on both sides. So when I get done with this, I'm going to have x equals -5 over 3. So I actually get a fraction for my answer. I'll zoom out so you can see everything. Okay. Now the reason why I have a fraction for my answer, technically the reason why I have a fraction is because of this leading coefficient right here. That's the only reason. But I know what my two numbers are going to be. So my solution set is going to be -5/3. And what was my other answer? -1. That's going to go right here. And I'm done. That's how you use rainbow method. And I'm going to have 4 problems like that on the classwork. Okay? I'm going to check this, and then I'm going to let you guys go. Okay? So let's check. Let's do the whole number first. How about that? Let's check x equals -1 and see what happens. So if I let x be -1, everywhere I see an x up here for my original equation, I'm going to let x be -1. So I'm going to have 3 times -1 squared plus 8 times -1 plus 5 equals 0. I'm just taking that original question and I'm just letting every single x be -1 and seeing what happens. So here, I know that -1 squared is actually going to give me a +1. So I get 3 times +1 plus -8 plus 5 equals 0. Right? So far, so good. 3 times 1 is going to give me 3. Plus -8 plus 5 equals 0. And then what you'll notice is, if I actually add these two numbers together, the 3 and the 5, I'm going to get +8. So this is actually going to be 8 plus -8 equals 0. So I get 0 equals 0, right? So that's a true statement. I know that -1 is going to work. Now let's check the fraction. This one is a little bit more difficult, but I'll show you how it works. So let's go ahead and check x equals -5/3. Okay, so for this one, I have to put in -5/3 for x, everywhere I see an x. So I'm going to have 3 times -5/3 squared plus 8 times -5/3 plus 5 equals 0. So all I'm doing is I'm getting that original equation and I'm just letting x be that fraction that I found. Okay. Let's do the squaring part first. What happens when I do -5/3 times -5/3? I'm going to get a positive fraction this time. I'm going to get 25 over 9. See how I did that? 5 times 5, 3 times 3, 25 over 9. And then over here, I'm going to do 8 times 5 is 40. So I'm actually going to get -40 over 3. And then I add 5 at the end to get 0 somehow. Okay, so far so good. All right, so now I'm multiplying 3 times this fraction, right? And what I'm going to do is I'm going to end out cross-canceling. So if I cancel out the 3 right here, this 9 is going to have to cancel out to give me a 3. So I'm actually going to have 25 over 3 right here. Minus 40 over 3 plus 5 equals 0. Okay, you with me so far? I know this is getting kind of complicated, but I'm just doing this all in my head. So when it comes to fractions, as long as you have a common denominator, you can add the numerators. So what's 25 minus 40? -15, right? So now I'm at the point where everything should start simplifying. 15 divided by 3 is 5, so I'm actually going to have -5 plus 5, and then you see how I get that 0 equals 0 at the very end. So this fraction actually works.